Yes, hey fam, welcome back. And since I uploaded a video on Caesar hash, it makes sense that I do one on running hash also. And running hash is also a form of hashing algorithm. It can be called an algorithm. It's also like very basic, and the ideology is also pretty simple. Imagine you have a sentence like A B C D E F, and then you will have a key. Imagine the key to be the key can be of any length. For the simplicity, now let's just consider it to be A. So now what you do is for every letter in the first one, the first string, you will add the value a to it. That's all. Like you just convert it to ASCII value and add the ASCII value of the actual key, and then convert it back to character, meaning that the entire string will be completely jumbled, and until and unless you have the key, you won't be able to like read it back. So yeah, again, it's like pretty simple. So let's directly jump into coding it up. So let's call it again. There's no initialization required for it. You will just have two methods, and again, both the methods will be like pretty similar. So first we'll have the encrypt one. This one will be to encrypt and one will be to decrypt. And again, just like previous video, let us just have two pointers so that since both will be like almost same, let's have two pointers. And just we will have the self over here, mainly because it is inside the class called running hash. You will have the text to encrypt and then you will have the key. Yeah, this is pretty basic stuff. So you will have an answer variable. And then so what you'll do is you initialize two values, I comma j, both to 0. And now for yeah, the make note that the text is bigger than the key. Or yeah, text, the thing is, it does not matter if the text is bigger or smaller than the key. For letter, letter in the text. No, let's make it for I in. So now what you do? Take the value of the actual text. So value of the text or the letter. Let's call it letter of text is text at the position I, and letter of the key is key at position J. Now what you do? Yeah, let's make our life more simpler. Let's directly convert it to the ASCII value using ORD. And after doing ORD, what you can do to this, you just add the ASCII value of the key for encryption, and for decryption, you just subtract the value. And after doing that much, take this value, convert it to char. After converting it to character, add it to the answer. Yeah, it's that simple actually. Yeah, yeah, if you do just this much, it won't work properly. You just have to have two check conditions for it, and so increase j by 1, and by any chance if j becomes greater than the length of key, if j becomes greater than or equal to the length of key, then just set j back to 0. Yeah, I think that's all it. Yeah, I told you it's like pretty simple. So let's define the class running hash. Let's call it hash. Hash is actually result keyword, so let's call it uh, encryptor is equal to the class of running hash. So let's have a string actual text and actual text, and let's have it. I don't know. Hello, my name is, yeah, SpongeBob reference. And let's have a key also, and let the key be SpongeBob. Yeah. And now let the encrypted, let's encrypt the text. Encrypted text is the encryptor dot encrypt the actual text using the key. And decrypted text is actually the encryptor dot decrypt the text and the actual key. Yes, and that's all it now. Just let's print out everything. Actual text, and then let's give a new line, and then the encrypted text, and then the decrypted text. Yeah. And now, if you think it will work, you are absolutely wrong because it is not actually actual text over here. You have to give the encrypted text. And now let's check it out. And yes, as you see, this was your actual text, but on encryption it became some random nonsense which you can not at all decode. But and on again decrypting it, you are actually getting back the original text, and there is no loss or anything. And yeah, let's make it more big or something. And if you just let's just make it A and check out. And again, what happened is everything got added directly. So for H, the ASCII value of A was added, which will become H. And yeah, it is completely nonsensical, and without knowing what the actual key was, like what you will never be able to decrypt it. And yeah, let's make it much more big so that it looks cool. And now let's actually have some text itself. Can I? Lorem would be easy to. Okay, let's just make a .html file, and it's .html. And over here, and let's have a div. Inside this, let me type lorem. Yeah, this is a very good way to generate long strings of text. Let me make it lorem 100. Let's make it LLORM. So if I make it lorem 100, it will give me 100 lines of lorem, 100 characters of lorem. And yeah, just let's put it in running hash, and let's call this. When you run it, let's make it. Yeah, I think when you add too much text, it becomes very difficult to read. So let me just remove. And as you see, you have then to protect. And yeah, let's just change the key. While giving a key, let's make it some. If you give some wrong values key, so now what will happen is Okay, yeah. Since the key is not proper, the actual text is throwing some error, and if you make it zero, and yeah, if you don't provide the proper key, either the program will throw error because the character went out of range, or yeah, obviously you should know why without having the key, it won't work. Even if the key is case sensitive, so if you call hello from key, this also will not work, and you are getting some complete nonsense. But when you make it hello from key properly, it works. Yeah, and I feel it's pretty cool. See, since only H was made different, the only the places where H is there, those values are changing. Let us make it help in, I don't know, help in. Yeah, again, see, as soon as you change the key or something, it will throw an error. And if you actually don't want to like show the errors, you can use try catch blocks or something. Yeah, that's all. It was a pretty small and simple way to do encryption. And just thank you, Grand DSA.